Momentum.
Well, welcome to MV Tutors. We're talking momentum. Well, what is momentum? Well, momentum is just basically the product of mass times velocity. Now, why do they use P? It's basically because they ran out of letters. They can't use M because M is already taken by mass, so they just pick P, and that's it. Now, what's important about momentum is that momentum is actually directly proportional to mass, and it's also directly proportional to the velocity. What does that mean? It means that if the mass is bigger, assuming that the velocity stays the same, the bigger the mass, the bigger the momentum, and the smaller the mass, the smaller the momentum. Same can be said for the velocity. Momentum is directly proportional to velocity, meaning the bigger the velocity, the bigger the momentum, assuming that the mass stays the same, and the smaller the velocity, the smaller the momentum. Okay, so now that demonstration just shows a change in momentum. Just another example of momentum where an object moves one direction, bounces off, and moves the opposite direction. It's just a case of momentum. It's a question you can get in the exam.
Momentum again.
Well, that one there just showcases another example of momentum where the object does not bounce, but it just sticks to what it's bouncing. Now, velocity there is 0 when it sticks. That's one thing to note. Just an arbitrary.
Well, introducing Mr. Time.
Well, very often you get people asking you what's the difference between momentum and impulse. Well, basically, impulse is just a change in momentum, and it introduces time into the equation. Now, let me just derive from you how impulse, or rather the change in momentum, comes about using Newton's law. Watch this. Okay, let's look at this real quick. We got Newton's second law, if you remember it, and it says a force is equals to mass times acceleration. So we keep the mass the same, but we know that acceleration is changing velocity divided by changing time. We also know that actually momentum is equals to mass times velocity, right? So if you look at this top part over here, you can actually see that over there we have the momentum. So we'll call it a change in momentum, and then at the bottom you still have your change in time. Now this is still equals to force. Now if we take the change in time to the other side of the equation, then we'll be left with a change in momentum there, and that, ladies and gentlemen, is impulse. Just a change in momentum. Now, impulse is directly proportional to force and also directly proportional to time, meaning if you increase the force, as you can see in that demonstration, there is a greater impulse, and also if you increase the time, there's also an increase in impulse. Now, if you could watch that video over there that just played now, you can see a demonstration there. That's where I spent a little time touching that car. It moved a little distance, but the more force I applied on it and the more time I spent on it, it moved a little bit further. But you know, considering everything else staying the same, that's how it is. Okay, let's talk about conservation of momentum. What is that? What does it say? it basically says that the total momentum of an isolated system remains constant. What does that mean? It means that if you add the individual momentums of the two vehicles, as I showed in that video there, if you add them up, they equal a total momentum. Now that total momentum is equals to the summation of the individual momentum. And lastly, let's just talk about elastic collisions. What is an elastic collision? Well, it basically just says that kinetic energy is conserved. All right, what does that mean? It means the kinetic energy before a collision is the same as the kinetic energy after collision. If those kinetic energies are equal, then the collision is said to be elastic. But if those kinetic energies before and after are not equal, then it is an inelastic collision. So an inelastic collision is where the kinetic energy before is not equal to the kinetic energy afterwards. Well, those are just brief highlights from me. Hope you enjoyed and understood.